Many organizations today, they find themselves just drowning in this sea of collected data, data that often remains largely unusable, or maybe worse, untrustworthy.
Right. It's a huge challenge.
It's really not just about gathering information anymore, is it? It's about transforming that raw stuff into a genuine strategic asset.
Exactly. Making it work for you.
So our mission today is to really get under the hood of a fascinating technical design document. Think of it like the ultimate playbook, maybe, for building a really rock-solid, secure, and scalable data platform.
Okay.
And we're using a specific real-world example, an SBK Customer 360 Platform Blueprint. It's actually titled Structuring Databricks for Success, Folders, Access, Governance.
Yeah, and what's really significant about this particular technical design document, the TDD, is just how comprehensive it is.
Yeah.
It's not just a plan, it's more like a strategic blueprint.
Right.
It aims to consolidate all these different data points, sales figures, support tickets, marketing interactions, digital footprints, all of it into one unified, reliable customer profile. So the document, it lays out best practices for organizing folders and artifacts within Databricks.
Okay.
And that's to ensure not just clarity and scalability, but also strong collaboration and, crucially, ironclad governance across all the teams and environments involved.
So this deep dive, it's really for anyone grappling with enterprise-level data management, wouldn't you say?
Absolutely.
Whether you're maybe a data engineer wrestling with pipelines or an analytics expert looking for trustworthy insights.
Or ML teams deploying models, platform engineers building the infrastructure.
Right, or even project leads trying to oversee the potential chaos. You'll see how this kind of structured approach, it doesn't just promise benefits, it seems to fundamentally change how data teams actually operate and deliver value.
That's the goal, yeah.
So let's get right into it then. What are the massive problems, the big headaches, this meticulous document is actually trying to prevent? Yeah. Why put in all this effort for such a detailed blueprint?
Well, the core purpose is, of course, things like clarity, scalability, collaboration, governance. But maybe think about it this way. Imagine an organization where data's just dumped everywhere. Inconsistently named, permissions are a total free-for-all.
A chaos.
Exactly. You quickly end up with these data swamps, just massive data graveyards nobody trusts or can actually use effectively.
Right, I've seen that.
So this blueprint isn't just about organizing files. It's really about preventing that silent, kind of insidious decay of data trust and usability that costs organizations millions.
Right.
Millions in wasted effort, missed opportunities.
Wow.
And this structured approach, it applies to all Databricks workspaces that support complex workflows, like this Customer 360 platform, across dev, testing, and of course, production.
Okay, and what are the sort of underlying capabilities that make this structure feasible? You can't just drop this kind of sophisticated blueprint into any old environment.
Right. No, you can't. This document operates on a few really crucial assumptions.
Like what?
Like, that Unity catalog is enabled for central governance. That's huge.
Okay.
That Git integration is basically foundational for version control.
Right.
And that CI/CD workflows, continuous integration, continuous delivery are adopted for automated deployments.
Makes sense.
It also specifies using Azure Databricks, specifically with enterprise-level workspace governance features turned on. These aren't just nice-to-haves. They're the underlying tech creating the robust backbone for this whole design.
Okay. Let's talk about bringing some order to that digital wilderness then.
Yeah.
How do they actually propose organizing everything, starting at the very top level?
Yeah.
The folder structure. What are the main strategies?
So there are basically two primary architectural approaches for that top-level structure they outline. One is environment-based, so you'd have like a shared folder, then maybe Customer 360 for the project, and inside that, distinct folders for
development, sandbox stuff.
Exactly. Tests for integration testing, and then prod for all the production-ready assets. It neatly separates your environments.
Okay, that makes sense.
Yeah.
And the alternative way to structure that top layer?
The alternative is more team-based, still under that shared umbrella, though.
Right.
So you might see something like Customer 360 data engineering for all the ingestion and ETL work.
Okay.
And Customer 360 analytics for dashboards, reports, that kind of thing. And maybe Customer 360 MLOps for machine learning models and their training workflows. So each team gets its own dedicated space.
So it sounds like a choice based maybe on how an organization prefers to segment its work, its teams.
Pretty much, yeah.
But regardless of that top-level choice, what about the subfolders? Within each environment or team space, Do they get more granular?
Oh, yes, absolutely. Within each of those environment or team-specific folders, you'll consistently find specific subfolders. Things like notebooks for exploratory analysis,
Right.
jobs for scheduled tasks, pipelines for Delta Live tables, or other ETL processes.
Okay.
DBT models, if you happen to be using DBT, tests obviously for quality checks, and docs for all the documentation. This uniformity within each segment is really key.
So once you have your folders all structured nicely, the next layer of organization that just becomes absolutely critical for clarity, avoiding that chaos, especially with a big team, is naming things consistently. Why is that so non-negotiable?
Oh, I once worked on a project where you'd see file names like report final v2 really final new.csv.
Oh no, I know that pain.
It's exactly that kind of nightmare that consistent naming conventions prevent. It's not just about tidiness, it's about reducing what they call cognitive load.
Right.
Without clear naming, even the most robust data platform can just quickly fall into chaos. So this blueprint, it mandates clear patterns.
For example.
Well, notebooks might follow a numeric and descriptive pattern, like ungreen one is Scrum data, jobs
Yeah.
are descriptive, maybe load web events dev.
Okay.
Pipelines specify their purpose, like curate customer gold profiled load. And tables, crucially, are categorized into layers: customer bronze, customer silver, customer gold.
The medallion architecture.
Exactly. So when a new engineer joins, they don't spend days just trying to figure out what customer data dump final actually contains. It's instantly clear, which dramatically cuts onboarding time and, importantly, reduces errors.
Okay, so we've got the data organized in folders, named clearly, but the real cornerstone of any enterprise data platform, especially when you're dealing with sensitive customer data, has got to be trust and security.
Yeah.
How does this blueprint ensure data access is really tightly controlled and sensitive info is protected?
Yeah, this is where Unity Catalog truly shines. I mean, before Unity Catalog, trying to manage data access across multiple Databricks workspaces was a huge operational headache.
I can imagine.
It often led to inconsistent permissions, data sprawl, just problems. So this document leverages Unity Catalog as this unified governance layer that sits above all the workspaces,
Okay, above them all.
which lets you centrally define permissions at the catalog level, schema, table, even down to the column level. And those permissions instantly propagate everywhere.
Oh.
So the blueprint specifies one main catalog, say Customer 360. And within that, it defines those three critical schemas we mentioned: bronze, silver, and gold.
And just to recap, what do those bronze, silver, and gold schemas represent in a practical sense? And why that specific layering? Is it just convention?
It's more than convention. The layering is really crucial for data quality and consistency. Bronze is your raw, immutable landing zone. Data exactly as it first arrives, warts and all.
Untouched.
Right. Silver then holds clean, harmonized, transformed data. This is where basic quality checks happen, standardizations occur.
Getting better.
And gold contains the highly curated, often aggregated data that's specifically designed for analytics, for reporting, for machine learning consumption. So this progression ensures data consumers are always working with trusted, quality-controlled information.
Okay, so how do they then precisely control who sees what data within those layers, making sure only the right people access the right level of detail?
They use role-based access control, RBAC, really effectively. For instance, a marketing read role might be granted select permission on, say, all tables within this FBK Customer 360.gold schema.
Okay, so read only on the final stuff.
Exactly. Marketing analysts can only read the final curated data. But contrast that with, say, an Engwrite role. They might get create, select, and modify permissions, but maybe only on the SESBK Customer 360.silver schema, allowing data engineers to work with the clean data for transformations, but perhaps not touch the raw bronze or the final gold directly.
I see.
And Unity Catalog can even auto-grant these permissions on future objects created in those schemas, which is incredibly efficient. It prevents that configuration drift where things slowly get out of sync.
That auto-granting sounds powerful.
Yeah.
But this raises a really critical question. What about protecting the really sensitive stuff? Things like emails, maybe social security numbers. How do you protect that while still making necessary data available for legitimate uses?
Yeah, this is where the blueprint leverages Unity Catalog's sort of more advanced capabilities. They implement specific, really fine-grained policies just for those sensitive fields.
That work?
Well, for row-level access, you can create something called a region policy. that could, for example, restrict rows based on a user's identity, maybe their group membership, or a specific attribute like EMEA region.
Okay.
And this policy gets directly applied to a table, let's say customer profile. So users only see data rows relevant to their authorized region.
Ah, clever. And what about masking specific columns? So a user might see the record, the row, but not the sensitive piece of data within it.
Exactly that. They define column masking policies. So for an email mask, the actual email column might just display, say, masked,
Right.
unless the user happens to be part of a special PI access group, in which case they see the real email address.
Okay.
And similarly, for maybe in a thin mask, the SS end column could just show up as NULL, unless, again, the user is in that privileged PI access group. These policies get applied directly to the columns themselves. It ensures really robust, context-aware data protection without needing to create multiple copies of the data.
That seems incredibly powerful and flexible. So with all this meticulously structured and governed data, how do they ensure that the code, the processes built around it, are reliable, consistent, deployed without, breaking things?
Yeah.
It's one thing to organize files, but another to ensure the actual data transformations are solid.
Yeah, absolutely. This is where Git integration and CI/CD become, well, non-negotiable, really.
Okay.
The document mandates a pretty rigorous repository structure, something like Customer 360 repo. And inside that, you'll have SRC for notebooks and workflows, tests, docs, and crucially, a .github folder or similar for the CI/CD workflows.
Right, the automation piece.
This is your safety net. Every single piece of code is version control. So if something breaks in production, you can instantly revert back to a known working version.
Essential.
And CI/CD, continuous integration and continuous delivery, automates that whole journey from a developer's laptop all the way to production. Once code is reviewed, approved, automated pipelines kick in, run tests, package the code, deploy it. It eliminates manual errors and helps ensure that what works in dev actually works in production reliably. Every single time. It's really the backbone of operational excellence for this kind of system.
And beyond just using Git, are there any particular conventions this document recommends for managing the types of code itself? Maybe distinguishing between, say, exploratory scripts and those production-hardened workflows?
Yes, definitely. There's a clear division of purpose outlined. So .py files, standard Python scripts are designated for production workflows, things that need to be robust, repeatable, testable.
Okay.
In contrast, .ipnb files, the Jupyter notebooks, are typically used for exploration, for interactive development, maybe initial analysis.
Right, more experimental.
Exactly. And this distinction helps manage the code lifecycle. It helps prevent, experimental notebooks from accidentally making their way into critical production pipelines.
Makes sense. And what about managing the actual jobs, the scheduled processes that run these critical pipelines? How do they ensure traceability and smooth operations across different environments?
Yeah, job management standards are super critical for traceability and just smooth operations. The document outlines that jobs should be assigned descriptive tags.
Tags like
nvdev or project.customer360. This makes filtering, auditing, and even cost allocation much easier.
Okay.
Naming conventions are also descriptive, like load customer demographics prod. Tells you exactly what it does and where it runs.
Clear.
Jobs are also organized into environment-specific folders within Databricks, like JobsDev and JobsProd. And importantly, they have configured alert policies tied to them for monitoring.
So you know if something fails.
Immediately. This whole standardized approach significantly improves searchability, makes debugging easier, and gives you much better overall observability. You can pinpoint issues faster and ensure things run on time.
Okay, what about building the actual data pipelines themselves?
Yeah.
The ones that transform data from that raw bronze state up to the curated gold? What tools and practices are highlighted for that specific task?
So Delta Live Tables, or DLT, are highlighted as a really crucial tool for building these modern, robust data pipelines. DLT.
Okay.
And they follow a clear structure within the production pipelines laid out in the document. You see examples like dltnistwebevents.py for bringing in raw web data,
Right.
or dltcuratecrm.py for cleaning up CRM records in the silver layer, and then dltbuildcustomergold.py for actually creating that final unified customer profile in the gold layer.
And the appeal of DLT.
A big part of the beauty of DLT is its declarative nature. You basically define what you want the end state of your data to be. And DLT handles the underlying execution, the orchestration, dependency management, error handling. a lot of the complexity.
And I think you mentioned earlier, these pipelines can actively enforce data quality. That sounds like a huge benefit for building trust.
Exactly. This is incredibly powerful. These DLT pipelines leverage what are called decorators. They're like special tags in your Python code.
Okay.
So at DLT.table isn't just a comment. It tells Databricks, hey, automatically create and manage this table, track its lineage, handle updates. And then at DLT.expect is really a game changer for data quality. It lets you embed data quality rules directly into your pipeline code.
Like what kind of rules?
You could say, this userid column must never be null, or transaction amounts must always be positive, or email addresses must match a certain pattern.
Okay.
And if a rule is violated when data flows through, the pipeline can automatically flag it, maybe quarantine the bad record, or even drop it entirely based on how you configure it.
So it ensures only high-quality data lands in your gold layer.
Exactly. It minimizes the need for separate, complex data quality frameworks and maximizes the integrity of your final data sets with much less manual intervention.
Okay, so beyond the Unity catalog governance, which sounds very comprehensive, what other layers of permissions or access control are mentioned to really lock things down and maintain order?
Right, there are other layers. They also implement folder and notebook ACL's access control lists.
Okay, ACLs.
These restrict visibility and edit rights at the folder or individual notebook level, often by team or individual user. So maybe the marketing team doesn't even see the complex data engineering notebooks in the workspace browser, for example. Keeps things tidy and secure.
Reduces clutter too.
Definitely. And additionally, that role-based access control, RBAC, that we talked about with Unity Catalog, it goes deeper. They define specific roles like marketing analyst, data engineer, auditor.
Right.
These roles get assigned permissions not just across the different data layers, bronze, silver, gold, but also potentially access to specific tools or features within Databricks. It's this multi-layered approach that ensures strong data security. It also promotes seamless collaboration by limiting access only to what's necessary for someone's job. And it provides really clear auditability. You know exactly who can do what.
Okay, what about the data lifecycle? What happens to old data or old logs? Is there a strategy for cleanup and retention? Or does it just pile up forever, potentially becoming another kind of data swamp?
No, data hygiene is absolutely critical in this design. They emphasize it to prevent data sprawl and manage storage costs effectively.
Good.
So, for the Delta tables themselves, retention policies are clearly set out. For example, bronze layer data, the raw stuff, might be kept for 30 days,
Okay.
while maybe silver layer data, the cleaned version, is retained for 90 days. This controls how long the older versions of the data are available for time travel.
The ability to query past states.
Exactly. It lets you query the data as it looked at a specific point in the past, which is great for debugging or auditing, but you don't want to keep that history forever necessarily.
Right.
Notebooks, too, are meticulously archived. They mention archiving them to Git monthly, automated via a scheduled GitHub action, like a cron job.
Okay, so they're backed up but maybe removed from the active workspace.
Precisely. And job results and logs, which can accumulate quickly, are configured to auto-expire after, say, 14 days. That's usually configurable through the workspace settings. All this prevents storage bloat and keeps things operationally efficient.
And finally, documentation. You mentioned a docs folder. Why is documentation treated as so crucial in such a complex setup? Is it really more than just a nice-to-have? Is it truly strategic?
Oh, absolutely it is. In this context, documentation, typically stored as markdown files right there in the docs folder within the Git repo, is critical for clarity, accountability, and the long-term sustainability of the platform.
What kind of docs?
It includes things like a comprehensive system overview, the big picture of the Customer 360 architecture. It defines the schemas for key entities. It maps job ownership, crucially, with contact details.
So you know who to call when something breaks.
Exactly. And it lists external data contracts details about the inputs, like from CRM systems or web tracking platforms. This isn't just reference material.
Right.
It ensures rapid onboarding for new team members. It provides clear accountability when issues inevitably arise. And it maintains critical alignment with those external data providers. It really reduces that dangerous tribal knowledge and makes the entire platform more resilient and understandable over time.
Okay, so after taking this pretty detailed journey through the blueprint for the SBK Customer 360 platform, what does this all really mean for someone out there listening who's looking to manage a complex data platform effectively? What's the ultimate takeaway here?
I think the main takeaway is that this folder structure and governance model, which was meticulously designed for this Customer 360 initiative, it provides a really battle-tested blueprint, a blueprint for building truly scalable, secure, and importantly, maintainable data workflows.
Hmm.
It's about more than just keeping files tidy. It delivers unified access control through Unity Catalog. It provides built-in readiness for automation via CI/CD and Git, and it creates unparalleled data transparency for everyone involved with customer data. It's about turning data into a truly reliable and actionable asset.
And who ultimately benefits the most from this kind of meticulous planning, this comprehensive architecture?
Honestly, everyone involved with the data. By adhering to this kind of structured approach, the data teams themselves can dramatically accelerate their development cycles. They spend less time fighting fires or deciphering messy code. Right.
Operations gets improved transparency. And most importantly, the business users, the decision makers, they can build unwavering trust in the data across all functions because they know it's governed, quality controlled, and secure.
So it builds confidence.
Exactly.
Oh.
It's a comprehensive approach for not just building, but actually sustaining and evolving reliable, future-ready data systems.
We've taken a really deep dive today into the nuts and bolts, really, of organizing a Databricks environment for a massive project like a Customer 360 platform. It's quite a testament to the power of thoughtful, structured planning in this whole world of data.
Yeah, and what's really fascinating when you look at blueprints like this is how these incredibly detailed technical designs, they underpin the reliability and the trustworthiness of almost every information system we interact with every single day.
Hmm.
All that hidden complexity, the meticulous planning like we've discussed, that's what ensures the data you rely on, whether you realize it or not, is accurate, secure, and actually ready for use when you need it. So, thinking about that, what does this all mean for you listening right now? Maybe next time you interact with a system that clearly leverages vast amounts of data. Perhaps you're checking your bank balance online, or looking at a personalized product recommendation, or even analyzing market trends for your job.
Yeah.
Take a moment and consider, what happens when organizations don't have such a detailed blueprint in place? What might be the real-world impact, maybe unseen, on the quality of that data, on its security, and ultimately on your own trust in the information you receive?
It's a good question to ponder.
It really highlights the critical, often invisible role of thoughtful data architecture in our increasingly data-driven world, doesn't it?
It certainly does. The foundation matters.